Parabolas have a lot of uses. Well, I should say quadratic functions have a lot of uses to them because they are one of the simplest functions that has a maximum or a minimum. And we can use that in solving problems like this, where we're asking what is the greatest possible enclosed area? In other words, what's the maximum area? And as long as we can set this up in a way that we get a quadratic from it, well, we know how to find the maximum or the minimum because we know that it's just a vertex. So let's go ahead and draw this. Whenever you can draw a picture in mathematics to describe something, it tends to help you figure out how to write an equation from it. So we have a rectangular corral. It looks like this. It's just some fenced-in area. And we're going to split it into two pins of the same size. So we're just going to split this thing down the center. So we have two pins of the same size, and we're asking what's the greatest area possible if all of this edge stuff, even the center here, is made from 300 feet of fencing. That's all we have to use. So how can we orient it or divvy up the sides? How can we divvy up the 300 feet through all of this shape so that we have the maximum area? Well, let's go ahead and give some variables on this shape here. First off, this side is going to be x, let's call it. And this side here, we're going to call it y. Now, it's important to note if this is y, that means this side is y as well. And these are also x because they're going to be the same sized pin. Okay, of course, we can actually cut this up because these two portions are going to be the same thing. So you could say each one of these is 1/2 y. We know that's true because these are going to be the same sized pin. And if we're asking what is the greatest possible enclosed area, if we're given 300 feet of fencing, well, 300 feet of fencing is going to be adding up all of these sides. And I have all the sides labeled, so let's go ahead and add them up. We have x plus x plus x, that's these three inner bits. And now these four portions, that's going to be 1/2 y plus 1/2 y plus 1/2 y plus 1/2 y. This is the perimeter. And that perimeter of the entire shape is going to be equal to the fencing we have. Okay, that gives us 3x plus 2y equals 300. And I can solve this thing for y, giving me y equal to, I'm going to subtract 3x, divide by 2, and get 150 minus 3/2x. This is just a linear function. The problem, though, is that this doesn't tell us anything about the area. This is the perimeter. And we have some restrictions on how the perimeter can be made up, right? If we increase x, y has to be decreased, and vice versa. Now, how do we find the enclosed area? Well, all we're trying to do is maximize the pin size. This is a pin, this is a pin. We're trying to maximize them according to these constraints. Well, what is the area? The area is length times width. So if we can maximize the length times width of this one, that's the same thing as this one, and then they'll both be maximized. So if you maximize this, we're going to get x times, well, I should say the area of this thing is this, right? That's the area. And all we're trying to do is find the maximum of this area. Well, this isn't a quadratic equation, right? Because we have two different variables. However, we know what y equals. Y equals 150 minus 3/2 x. That means I can plug that into here, giving me x times 1/2 150 minus 3/2 x. This is a quadratic equation. It's going to be, let's see, 75x minus 3/4 x squared. And if we're trying to maximize this area, well, this is a quadratic. Does it have a maximum? Yes, because a is negative. we know that it's going to be open downward. It's going to have that global maximum. And where is the maximum at? That happens at the vertex. So let's go ahead and find the vertex. A is this guy, B is 75. So the vertex is going to be at x equal to negative B is 75 over 2 times A. A is negative 3/4, so negative 2 times that's going to be negative 3/2. Multiply by the reciprocal. That's going to be 25. Negative and negatives cancel. I forgot to do that. The negatives cancel here. And we get 50. Well, if x is 50, we know that y must be 3/2 of 50. That's going to be 75. 150 minus 75. Y must be equal to 75. If this y was 75, this whole thing was y, right? So that means that each of these portions is going to be 37.5. And 37.5, 37.5, and of course x is just 50. So those are all 50. If you add them up, this is 75 plus 75 is 150. 50 plus 50 plus 50 is 150. That gives you 300 when you add them up. So we know that it's going to be 50 by 37.5 pens, and we have 2 of them, and that will give us the maximum cubic feet, or sorry, squared feet for each pen. Okay, if we have a ball that's thrown in the air, top of a building, its height is in meters per ground. Meters above ground is a function of time, of course, because when you have a thing like this, it's moving through time. So at each time point, you're going to get different heights. And how long does it reach a maximum height? What is the height it was thrown from, and when will it reach the ground? So it's from the top of a building. I'm just going to draw a building like this. Here's the ground. Somebody's throwing the ball from here, so it's going to be balls being thrown like this. It goes up, and then it goes down like that. And it's not apparent why this is a quadratic, but this is a quadratic function because gravity is quadratic in nature. This equation actually comes from what are called kinematic equations, and if you study physics at all, you'll be able to see that. Okay. How long does it take to reach the maximum height? The maximum height is going to be, of course, here. We know that it does have a maximum because A is negative. That means it's going to be open downward, as you can see on this graph. And the maximum, well, that's going to be at just the maximum of this quadratic. So we know that's going to be t equal to negative b over 2 times a. A is, let's see, 4.9. That's going to be negative 9.8. Those cancel. And then that's going to be at 24 over 9.8. 2.44, let's do 449 seconds. Yeah, time was given in seconds, so it's going to be after 2.449 seconds, the ball reaches its height, its maximum height, and then what height was it thrown from? Well, that's the same thing as asking it when time is 0, what's the height? Negative 4.9, 0 squared, plus 24 times 0, plus 8. That's 0, that's 0. We get 8. So it's from a height of 8 feet, or sorry, 8 meters above ground. And then finally, it asks, when will it reach the ground? Well, when it reaches the ground, if you think of this as a function like this, the height is at 8, so it's going to go 1, 2, 3, 4, 5, 6, 7, 8. We said that it was, let's see, 1, 2, 3, 4, 5, 6, 2.449. That's just slightly under 2.5. I didn't find what the height was. To find the height, you just plug 2.449 into here, and that'll give you your maximum height. It doesn't really matter for our purposes. This is kind of what the quadratic looks like that. This is at 8. This is right here is 2.449. And you can see that it does hit the ground at some point. And the question is, what time does it reach to hit the ground? Well, if this is our function, this is h of t, then all we're looking for here is the x-intercept. Of course, a quadratic goes both ways. So we're going to get two x-intercepts when we find it. This one's going to be negative. This one's going to be positive. So we don't want to have the negative one because that doesn't make sense. We want a positive one here. And all we're asking is, when is h of t equal to negative 4.9 t squared plus 24t plus 8? When is this equal to 0? This is a quadratic equation. To solve this, we can factor it if possible, or in this case, probably better to use a quadratic formula. So it's going to be negative b plus or minus b squared minus 4ac all over 2 times a. Okay. Go ahead and calculate this. Get negative 24 plus or minus the square root of 732.8 for negative 9.8. Doing the plus version on top, we're going to get 3.0702 over negative 9.8. And doing the minus version on bottom, we're going to get minus 51.0703. This is also 3 here. Over negative 9.8. We know this one is the negative because positive divided by negative is negative, and that one's not going to be what we want. This was t equals that. So t is going to equal this one, which is approximately equal to negative positive 5.2. So I have it as 1, 2, 3, 4, 5. My graph is wrong. It's actually about right here. So I can cut that off, and it looks like this. So it's in the air for a total of 5.2 seconds. And after that is when it will hit the ground. Okay, and I just wanted to show this real quick. The actual graph, we know what the equation is. We can see that my graph was way off because I didn't drop very high. I drew it like this, but it actually was a lot higher than that. And so I just plotted this actual function here. And you can see that the vertex is at 2.449. That's what we found, 2.449. The starting height was 8 meters. That's the same thing as the y-intercept. That's at 8 meters. And where it hits the ground is right here at 5.211. And that is actually what I found here, 5.211.